legacy and everything.
Okay, that's my face. Let's see. I can get the lecture up.
Yeah, just present. Take the presentation away. Go to your meetup. Go to that.
I'll go to the lecture real quick. 5. Sweet.
Is that one?
Yeah, present mode, please. Yeah, that's it.
Entire screen mode. Entire screen. Come on. Am I presenting?
Yep.
Coffee.
Yep. Cool.
It's awesome. Sweet. We have 3 people here.
Already? Wow.
Well, that's probably if you.
Probably you guys.
It's probably you guys, right? Last time I saw that, I felt so proud because I was like, oh look, people are remoting it, and then I was like, oh.
We're not.
They are technically remoting it.
No,
Also,
I mean,
like from locally.
we're not advertising it as such.
Yeah.
Do you want me to do that?
I mean, we could do that if we wanted to. We could remote it in. I think it's better in person though.
Yeah.
Yeah.
We do everything to make you happy.
Yeah.
And the other thing is that I didn't have much time to post this in other meetup groups. I usually do that in other meetup groups as well.
I posted it on LinkedIn.
Yeah, I did that before too.
It said 21 people were coming, and I'm glad they didn't because there's not that many seats in here.
So people will trickle in.
Yeah, they trickle in. It
Yeah.
takes about 15 minutes.
Yep.
To 30 minutes for people to really fully come in.
Yeah. Well, we can start without them.
Sure.
And usually the statistics, it's around 50% from the enrollment.
Yeah. It's free.
If it's above 50, then it's something really good, food or speaker. Or if it's below, then it's.
Yeah, I think we get about 50%.
Yes.
So are you guys all set up? You have
Yeah.
some sort of console
Class,
that you can
Python.
test
So where
stuff
we have
out
to
in if
be,
you want,
okay.
and if not, you can just take notes. It's all online.
Yeah.
I'm gonna catch up and
Okay, you're just gonna take it in. All right. Yeah.
Well, so what you can do is if you have a computer, there is something called REPL, REPL.it. Here, you can go to, you type in Python, and then here you have a full interpreter.
We should do some.
oh, this is easy.
Yes, I'd love to convert it to Python 3
Yeah.
because I found out about the support loss just recently. So you can do that. Oh, and this is, oops, do not do that. Do this one instead. No. So just REPL.
REPL.it.
And then for,
You could, is that this one here, that's like a notebook, right?
Yeah.
Yeah, you could even do it from there, right?
it's all online based.
Yeah, you could do it from your cell phone.
Yeah, I would recommend that though. What do you mean the DNS is not working?
Issues with the internet, so I switched it
Oh, there.
to guest.
There it works. Now it works. This is also cool. So for people, since we're kind of chatting a little bit, have you guys ever heard of pythontutor.com? Now, have you seen pythontutor.com?
I did not.
Start visualize your code. Yeah, this is awesome. Watch. I'm just gonna type in a bunch of Python. I'm gonna return 0 as usual, and then print hello world. So you just write some code in here. This is really cool. And I'm like starting to mix up different languages. Visually execute. So then you go here and you forward and watch what happens on the right. It like
That's really
literally
nice.
goes through your
Yeah.
code.
That's really great. Mm.
Yeah, it's cool. So if you ever wanted to see what it actually was doing under the cover, it's awesome. Or so I gotta go. I'll go log into my website real quick because I haven't. I'm still writing about this post, but I haven't gotten to really publishing it yet because a bunch of issues with the HTML. There's interactive code diagrams. This one was really cool. So I embedded it in here, but I just thought this one was really neat. So like it starts out, defines a function, and then it just keeps going through and look at what it does on the right.
Mm.
Just shows you the exact
Your index
tuple.
is still there.
Shows you the index. It's just awesome. It shows you the stacks and everything. I just thought this was the neatest thing I saw recently. You know, you can actually see the data structures on the right. Which we will cover these data structures today, but you can see it right there. It's awesome.
Yeah.
I like the neatest way to like visually show what's happening under the covers. It's kind of cool. I saw that like 2 or 3 years ago. And I totally forgot about it and was trying to figure out what the website name was, and then it popped up in a channel one day.
I see.
It's
great.
cool.
Yeah. It's great for beginners.
Well, even like if you just want to see what's happening, it's kind of cool. All right, so I think we should maybe do quick introductions, and then we could in 5 minutes I will just start.
Yep.
I'm just gonna put this up here ready. Do top. Just run a top on it and see what's hitting it. So I'll do myself first. So I'm Chris, and I think Python instructor. This is class 5. A little bit about my background. I've been working kind of indirectly with Python probably for 4 years, and a lot of my hobby projects are in Python. And probably for like the last 2 years or so, I wanted to teach a Python course because it's just something I wanted to do. Bit about my background. I work as one of the database engineers over at Salesforce. I work on their artificial intelligence product, and I manage the data. So it's like a lot of like data management type stuff. That's a little bit of my background.
Cool. I'm Marissa. I've been living here in Boston for about 1.5 years and working almost entirely in Python. And I've been programming for maybe like 5 years, in different jobs and in school. And I've got a lot of experience tutoring, mainly like mathematics and physics, and I just thought it was a good step to share my programming skills and help people learn more about Python. Yeah.
Thank you.
I'm Meng. My team and I manage about Postgres databases, and we figured the next step is I need to learn a little bit about Python because we have some association. I figured it's good to learn within a group. So that's what I am.
So the irony is I manage a lot of green plum databases.
You are.
A lot of what?
Green plum.
I manage, so I have about 1,200 of them running at the moment, which is kind of cool. But yeah, basically running, most of my stuff is like running lots of green plum databases, and it's just the plumage for like the predictive analytics team.
Nice.
I'm Felicia, so I'm a scientist. I work in a farm startup company, and I'm just studying Python for fun.
Awesome.
My name is Arian. With the local company Cortec, we do data analytics and healthcare records, and looking for Python.
Hello, Ming, so you're the only person I don't know. So I'll just talk directly to you. My name is Cal. I'm the founder of Health Innovators. Health Innovators is a digital health incubator. We help people start healthcare startups using technology, primarily software. So we provide them all mentorship, advisorship. We help them build minimum viable product, and we also help them get investment and early stage customers. So this is our effort to build a developer community, so that we want to combine the developer community with the healthcare community, which we have already built, so that we can together collaborate, come up with new solutions. So this is our effort to build a community of developers.
Yeah, sounds fantastic. Well, that's one of the reasons attracted me to the group is because of the healthcare element. I
Absolutely.
work for a company called Decision Resource Group. That's
Fantastic.
do analytics for healthcare.
Yes.
So I'm pretty new to the company, so I'm learning about healthcare domain.
It's the health data is untapped right now. It's a huge opportunity. Ultimately, we're going to get into advanced courses. We are teaching analytics, primarily R, and then we'll get into machine learning. Yeah, but starting with Python as a base.
So I guess we could get started, right?
Yeah.
So a bit about previous classes. We talked about, our first class was kind of print statements. The second one was variables, and we introduced people to like very basic concepts in Linux. So how to navigate a file directory, open files, edit files, save files, things of that nature. Third one, we covered a bunch of loops and conditional statements, so if-then statements and while loops. And then the fourth one was based on, the fourth class we had was what we call an application class. And basically we take 3 different applications and we use the previous class's material to kind of build things from scratch in an iterative fashion. Today's class is a little bit different. We're doing more of that theory-based class. So from this point on, we'll have like a theory-based class, and it's always going to be followed by some application type class. And the idea is we first get into the theory and the basics of the syntax, and then the next following class we really get deeper and let people practice that syntax so that they can build the skills and just understand the use case behind it. So this class we're going to cover what I call containers, and basically we start out with the concept of a string. We explain how it is a container, so a container for objects specifically, and then we get into concepts behind that. And we cover a lot of different data structures here, so strings is one of them, lists is another, we talk about tuples, dicts, sets, and then the very ending is probably the more advanced section. We'll talk about what's called comprehensions. So there's multiple different things called comprehensions, and they're shortcuts for building these other structures really quickly. So in the previous class we talked a little bit about what a string is, and a good example of a string up here is hello world. Everybody's kind of familiar with your first programming class. What exactly is that kind of hello world thing? Well, in Python it's actually a type of container where each character is set as an element of that container, and there's some kind of order to it. So, in hello world, the first letter is in the 0th index, the second letter is in the first index, E, and it keeps going on. So a string is a container which has an implied order. And the other important thing to notice about it is that every single element of a string is actually a character or itself a string. So we talked a little bit on the previous slide. What exactly is this second thing called an index, which is just a numbered list? That's actually used to retrieve things from a string or a container. So we'll do it real quick and I can show you. Oops. And I'm having problems getting to the top. Escaping. I am using CIC. That's fine. Worst case scenario.
No, she has the charger.
Oh, okay.
So I'm going to show
Let
this.
me know if you need help.
I'll do
connecting to-
real quick
Okay.
a
Network,
REPL
yeah.
session just to show this off a little bit. Get rid of visualize this. Get rid of my website. Not get rid of that. So a really good example of this, and we'll just do it over here. I'll do it up here. So on the left side, this is replit.com. If you want to get a quick session up, you can just do repl, repl.it. If you type that up, it gives you a little prompt. I'll show that real quick. So if you do repl it, you can open that. If you go down here, you can search for a language, Python. when you click there, it will automatically open up this session. We'll talk a little bit about indexes. So a good example is most people know the alphabet pretty well. An alphabet, let's do A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. There we go, alphabet. There's other ways to do it, but I haven't covered it so much. So this here is a container where A is in the first one. So this is the 0th index, and then it goes +1 through it. So if we wanted to retrieve that first letter, we could just print it on the screen like this. And you'll see right here that it has A. And if we want to get B, we just increment it by 1. In Python, by default, when we number something in a container, it always starts at 0 and then increments 1 each time. Another interesting thing about it is you can go from the back. So let's say we wanted to get Z, like the letter Z. We could do -1. And that gets Z. And what that really does is it takes the length of the container and then it subtracts 1 to it and then provides that letter. Let's do real quick, just double check. Yep. And then you can look at the example here. It does other letters, but basically that's conceptually how you can understand it is you can select anything in there. One thing to note is let's say we pick a number that's bigger than the list, you're actually going to get an error. You'll get a typical traceback error, and what it says is that the string index is out of range. So obviously, if your object only has 20 items in it, you can't go for the 25th item. It doesn't logically make sense. And the way that Python knows that, we'll just go to the back slide real quick one, is each of these objects generally has some kind of null indicator or null string. And so it will typically go through it, and if it hits that null indicator end of string object, then it's going to throw that error. And I think in Java we call that like a null pointer exception or something like that. Similar concept. So what is it actually doing under the cover? Well, each of these string objects has an index on top of it, and each of those indexes is associated with a specific number. So 0 is associated with H, 1 is associated with E, and it just keeps going that way. And I lost it. Where was it? So when we ask for the first position, it looks for that first index and retrieves exactly the value that's associated with it. Another important thing is something called a for loop. So a for loop, one interesting thing about strings or any type of container is that each container has a reference to the next container. So, if you have like a alphabet A, B, C, D, E, F, G, A has an association with B. There's a reference that points to the next cell. And that's how we preserve that order. And so what we can do is we can ask basically Python to go to the start of the container and then keep going to the next container until it hits that null marker. And that's what we call a for loop. And I'll show you a visualization a little later on, but I just want to show you more. Did I close Replit? Please tell me I didn't close Replit. Okay. So in this case specifically, we have alphabet there. We can do a for loop for A in alphabet, print A. And like previous classes, we talked about this concept of a conditional code block. So whenever you see this colon right here, we know that the code after it, followed by an indent, is a conditional piece of code. And so in this specific example, what it's going to do is we have this defined thing, the alphabet. It's going to start at A. It's going to take this A letter. It's going to assign it to a temporary variable A. And I think I actually did a little experiment. This is actually a global variable, but it assigns it to A. And then it uses it in this loop, just like you would see in a while loop or an if loop. And it will keep doing that each time. So the first time it will be an A, the next time it's a B, the next time it's a C, and it will continuously use that. So if we execute this really quickly, you're going to see A, B, C, D, E, F, G. it's going to take each single letter and just make that and transfer it over. And then just to show you that it actually is a loop, if we have I equals 0, and we could do print I, so that would typically be the index. A is the actual value in the index. And we can just say print loop just to show you it's looping. If we do this, oops, oh, update condition statement. Here we go. So just to show you that it's a loop, this code block here is the first iteration of that loop. So when it assigns A there, it's the 0th time, it's the 0th index, and this is a loop, and then you can see that it assigns B next. Does that make sense so far? So it's just kind of interesting. What you end up having is, it's the same thing, similar concept to a while loop, but the iteration is based on the members of that container right here. So I think it's easier to explain through a visualization. So where's the... And I am lost. Oops. It's not there. Oh, it's there.
Sure.
Yeah, that's
go for
fine.
it.
So we'll talk a little bit about like what an actual for loop is under the cover. And I'm just going to go up there really quickly explain it. So like in the previous lecture I mentioned, you have this container here with an end of string clause. And what a for loop really does is it says start here with the first letter. Use this, temporarily assign it to a variable, and use it in the code block. Then it triggers this reference to the next cell, and it continues that process. So it takes E, assigns it to the temporary variable, and uses the code block. And the important thing to really realize behind this whole process is this data structure, this container of letters, it implicitly has a value per member, but it also has that reference, and it's the reference that's dragging, which allows you to go through each of the members. And the way it knows that it's the end of the container is that special container, the special object in the ending, that's going to tell it to stop. Don't iterate any further.
Meaning there's not a pointer at the last one.
Yeah, generally what it is, and this is more data structures. I haven't looked at the actual implementation under the cover, but usually you have a special null character as the last actual object, last
So you
actual
still have
reference.
the reference, but when you get to the last one, when you open it, there's actually nothing.
Yeah. So what it typically, and I'm basing this on linked list, but it's actually something called an array implementation. But generally, how it works is you have that reference. And when it hits that last reference, it checks this for a null string, a null object. And if it is a null, then it stops the iteration. That's kind of under the covers, kind of how they typically implement that type of stuff. So, and once we get done with strings, maybe we can do some practice. I'll let you take over for some practice. So we can actually combine conceptually the concept of an index and also this for loop. Because if you have that giant container, you don't have to necessarily start with that first member. You can start with the third member or the fourth member and use that for loop, that reference to keep going on. So conceptually, starting with a different index and using that for loop, that's called slicing. And what you end up doing is you have this notation where you have a string, a start, and an end reference. And the start reference is whatever index you want to start at, and the end reference is the last thing you want to hit, basically. And what's interesting about this is you know that it's actually doing this iteration process, because if the start date is a higher index than the end, it just returns nothing. Because you can't iterate, you're not iterating backwards. Is conceptually how to think about it. So we can do this code real quick just so people can see it. Again, it uses the A, B, C, D, E, F, G, so alphabet, to show a little bit of what's happening. So here we have the alphabet as usual, and we're going to talk a little bit about slicing. So let's say alphabet, and I want to take the first 5 letters, right? Oops. Hopefully that actually is correct. I gotta go double check it. I think that's correct. So if you do that real quick, and we're going to take the first 5 letters, we're going to start with the 0th index, and we're going to go to the nth index, and the nth is always going to be excluding the last bound. So if the 5th index is going to be excluded there.
So it's up to but not including.
Yeah, it's up to but not including the end here. Do you guys see that so far? So let's say we wanted to do it again, but we just want to get the first 2 letters. We could do first letter is just 0 to 1. So we have A. If you want B, you go 0 to 2. A, B, 0 to 3. A, B, C. And then another thing that's worth noting is you can use negative indexes. Well, let's not do negative indexes yet. You can leave one of these blank. So if you leave both blanks, it implies that it's going to take the first element to the last element. So it's going to give you the whole sequence. And then if you wanted to start with the first element A, and you want to go through the first 5 like above, you can add 5, and it just replaces 0 here and goes to the 5th element. If you leave this 0, it implies that it's the last element in that array. And you can go to the first 5, it will exclude the first 5.
Nice.
Pretty simple syntax. It's kind of nice too. And then let's say that you want to go to the 5th to the last element. You can also use negative elements in here. So here we're taking the first 5, we're excluding the first 5 and the last 5, and we're only going to get the part of the element, the alphabet between that. What happens if the first one is bigger than the second one? You're going to get nothing. And the reason you're getting nothing is it's going to look for that first index, and then it's going to go right until it hits the second index. Well, if the second index is preceding it, there's no right to go to. So it just ends up giving you nothing.
But if you put a 13 subchance, you get an hour range.
Yep. If you do, you said 13, 20?
But 30.
Yeah, if you get 30, you'll get an error. Oh, maybe not. You don't get an error.
I was thinking hour range.
It's different for less than.
Maybe index is different. Okay, that's interesting behavior. I don't know about that behavior. It's a good question. I never actually tried that out. Just like an interesting little forward, I've actually had issues where the first index was bigger than the second, and it's caused a massive bug. So that's definitely worth noting. So I think we're pretty clear with the slicing. I'm going to show really quickly a slide of what slicing is too, so that people can get a better sense of it.
What was the example you just did where it didn't show an error? You did
30,
that 5 minutes ago.
index 30 to 0. Because alphabet doesn't have 30 characters, it returns null.
Yeah.
Oh, you have to look at the Python docs for that. That's one I don't know. So really quickly, like what is happening under the covers, we're applying both indexing and the for loop procedure simultaneously. So in this case, we're going to do hello as our string. We're going to start at index 4 and go up to 4 by excluding 4. And what it does is it first finds the first index, which is going to be E. Then it's going to use your for loop to grab the next letters. And when it gets to this 4th position, it treats it as if it's a null, or the end of the string. It just stops executing right here. And then what it's going to do is it's going to take these 3 things, concatenate it, and then it's going to return it to you. So first we talked about indexes. Second, for loop, where you start with the first element, go to the last. Slicing combines the 2 concepts. And what's interesting, so just kind of referencing this for the next object we're talking about, this behavior is going to apply to a lot of things we're going to cover today. So whatever you see here is actually quite applicable to, we'll cover something called a list, and it has the same behavior.
And how, if you want to say include the 4,
So if you wanted to include the 4, you would increment this to 5.
To 5.
So it'd be 1 to 5. Yeah. And that would force it to exit out. It would
Or
keep
you could
this
also
one.
leave it empty if
Yeah.
you want it to include the whole everything else up to the end.
But if you leave it empty, if this was a longer word, it would go
Then
to
you
the
get
end.
everything.
So we can also think of this, the number of items you're looking for.
Yeah, definitely. You can think of it as like you're looking at as a set of numbers within this index. Now, one thing a lot of people will ask, and this is the next slide real quick, one thing people will ask is, well, that's all great, like going one step at a time, left to right is great, but maybe sometimes I want to start from the back. Maybe I want to skip an element. I don't want to necessarily always go to the next one. So Python has this really cool behavior where you can actually skip numbers or go backwards. And it has to do with slicing actually has 3 parameters, and it's just assumed the last one is 1. So the first one is the start, the second one is the end, and the third one is called the step. And if you have 2 in the step, it's going to go retrieve every second element. If you have 3 in the step, it's going to retrieve every third element. If you have a -1, it's actually going to go backwards, so it's going to start right to left. Does that make sense? So this step is really useful because you can like reverse a list or a container that way. And actually, so I'll go show that. Oops. So I like to show it with numbers because I think numbers are a bit more intuitive. And we can call this numbers. I'll also do it with a word, so we'll do a word, hello world, since that's a common word. And so let's say we have numbers, and we want to go through the entire index. We want to go to the start to the end, through the entire array. But we want to go on steps of 1. That would be our like typical use case, because 1 is implied. So we'd get the whole set of range, right? So starts at 0, goes to the ending in steps of 1. If we wanted it to go in steps of 2, so that should be 1, 3, 5, all the odd numbers. We just put 2 and it will go in steps of 5. So let's just show it really quickly, both of them, so you can see it. So when we have a 2 there, it starts with 1, it skips 2, goes to the second position, 3, skips another one, goes to the 5th position, skips another one, 7th position, 9th position. If we want to do steps of 3, we just put 3 there, and now it's going into steps of 3. What happens if we wanted to reverse the order? We could do -1. And now we have the actual inverse order. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. By having steps of -1, it's going to start with 9 and go backwards.
So it will start as a second value. So if you have 1, 3, -1, it will start from the.
If you put a negative number on the step, it's going to actually reverse the order. It's going to start from the right side and go left.
But where from the right side will start if you put in additional inputs in the numbers.
So if you start with a positive number, it's going to go from the left side, the 1, and it's going to go to the right. And then the integer number you provide there is going to tell you the step size. So if you do 2, it's going to go 1, 3, 5, 7, 9. If you do 5, it's going to do 1 and just 5. If you put a negative number, what it's going to say is start from the right side, the 9, and then go backwards. So it'll be 9, 8, 7, 6, 5, 4, 3, 2, 1.
But you start with 9 right now because we didn't pass in anything before the -1.
Yeah, because it starts with 9. Yeah, because the first 2 numbers is the start and the end.
So which one will it take as a starting number if you're going backward? Does it take the first input or the second input?
If it goes, so going backwards, this first example, the start and the end are blank, so it takes the entire list. But instead of starting on the front, it starts on the end.
But if we start slicing it,
Oh yeah,
will it take the first input or second input as a starting point for going back?
So the way it works is it would take the start and end points, right? So let's say I do 2 and 2, so it starts at 2, and it goes to the 4th index, right? Let's do 5th because I want to exclude that.
Yeah.
So it's going to go take the 2nd index, 3rd, 4th as an element, and then start in the back and go backwards. Except it didn't. Oh. You have to do backwards.
Right. Okay.
So you have to start backwards because this.
That's interesting.
So you guys see that?
So you have to also swap the starting and endpoints
Yeah.
that you want.
So it literally acts like a reverse, basically. And then obviously, if you put a integer in here, it's going to do it as step size 2. And let's see real quick. And we're close to our first exercise. It's 2 slides away. So next thing we're going to do is unrelated to this index concept, but just some things you can put in your pocket. Almost all of these objects have these things called methods bound to them. And all a method is something that applies. It's kind of like you can think of it an action that applies to the object. So a really good case here is, I'm going to highlight 2 different methods here. The first one is if you have a string and then you use this lower with parentheses on it, it's going to lower the entire string. So if you have something in caps locks, like high in caps locks, and then you do dot lower, it's going to do high in lowercase. And then alternatively, you can do upper as well. So if you want to make everything uppercase, you just use the upper keyword. So we can show that real quick. So if we didn't have numbers, but we decided to put a sentence, hello, my name is Chris, is our sentence real quick. If I wanted the sentence to be lowercase, I could do sentence dot lower and print it real quick, and you'll see that all these uppercase things will go to lowercase. And then we can also do upper here, and that will do everything to uppercase. So you have this container which has the ability to iterate, which is to go forward based on a member's position. You have indexes, and then you also have these these things called methods attached to the object, which allow you to manipulate the contents.
I think you need some juice immediately.
Hmm?
You need some juice immediately.
Oh yeah.
We can switch computers, or if anyone has an
Yeah.
extra.
Felicia.
Is it okay if I could borrow your power? Okay.
I still have plenty.
Cool. Yeah, I was about to die in the middle of class.
We have a list of all the methods.
So we'll cover a command, but there's this command called help.
Okay.
So if you do help, I'll actually show it real quick. Hopefully the internet, hopefully Replit supports it because it uses, under the cover, uses a thing called Vim. But maybe it supports it. So if you go help and then str, which is string, it actually comes up with the documentation on the right.
Help. STR. Okay.
Yeah. And I was going to cover it later on,
Okay,
but
sorry. Okay.
oh yeah, but we could cover it now because it is kind of makes sense, right? So I like to kind of go through the help documentation. We can do it real quick, but this is really cool. You can put an object usually in here. Sentence might work. I think because it's a primitive, it might not. Yep, it doesn't. Won't work for a primitive. But you can put the class in there, and you'll get this documentation here. And this is really awesome documentation. All Python objects tend to be classes, so I'm covering classes later on. But those methods I mentioned, those are actually part of those classes. So we have these things called magic methods, which I won't really cover, but they are special methods with a double understring, and those are actually the plus symbol or the equal symbol or the in phrase. Those are special methods. Those are special things associated with symbols in the programming language. These ones that don't have double understrings, these are all the ones where you can do that are kind of more special. So capitalize, return a copy of the string S with only its first letter capitalized. So you can do capitalized, parentheses, and it would do capitalization. You can do counts. So if I didn't want to count it myself, I could just do count here. And that method should return a count. And I'm gonna comment this out. We should see that it counts. Takes at least one argument. Oh, maybe it's count a specific instance. So let's say count E. Nope, I gotta print it. Yeah.
Or you
count
have to
E.
have something in the middle to count whatever it is, not all the word. If you want to count the whole thing, you use LEN.
Yep,
Yeah,
LEN.
so it's different. Okay.
Yeah. But basically, you can read this documentation using the help function, and it will actually show you all these methods. And then if you really don't understand what's in here, for example, you can always take this thing like translate, and you can go string translate method Python online, and you can just look it up. And then look right off the bat, tutorial point says string method, string Python string translate method, and it goes through the documentation. So anything you see in help, if the help doesn't clarify it, you can always use the help documentation online.
What's the name of that place? Like a tutorial?
This is great. Tutorial Point's awesome.
Tutorial points? Okay.
Yeah, if you want a basic overview of any language, it's really great. It's kind of like WC3 schools or W3C, I don't know, it's W3C schools, but it's for like generic programming languages. So this help's kind of cool. So if one thing is if you forget something or you want to look if something's already implemented, you can use that help, and it's really useful. So the other ones I wanted to cover real quick are two other methods. One's the find method and the other one's replace. And find, basically you provided a pattern, a fixed string pattern. It will search the string to see if it can find it. And then if it finds it, it will return the index where the first instance of that match is found. And then the replace method, it looks for that instance and then will replace it with something you provide. So I'll show that real quick so you guys can see what the replace does. So let's say I have the sentence and I want to take that sentence, and in that sentence I want to see if the word my is present. And you can see my is right here, right? My. So we end up with 6. And if we do sentence 6 and then my is 2 letters, so 9, it should print my on the screen. You see how I did that? So find will tell you the index it starts with. My is 2 letters wide, so it should be index 7, 8. And then we want it, the last one's always exclusive, so we have to go to 9 to get that last letter. Now what happens if I took my and I wanted to replace it with something, which is a bit different? I can do sentence dot replace. I want to replace my, the first instance, with my with cow. And we'll print that real quick. Hello, Callian, name is Chris. So replace will find that pattern in the string and replace it. Only the first instance. I believe the second argument lets you do multiple. Find lets you look through the string, and if it's found, it will show the index. And if it's not found, I'll show you that real quick too. Let's say we have a sentence, and we find something, and I want to look for hamburger in that sentence, and there is no hamburger in that sentence. You'll get a -1. So you can see the -1 right there. So there's all these different methods. I always suggest if you want to do something, you can always Google and see if there's a method for it. It's usually a useful little thing to do. So that right there is our string methods 2.0. And the next one is Marissa will walk you guys through a few exercises real quick.
Cool. Alright, is there anyone that wants to actually go through this that doesn't have some kind of setup? Like Replit or your own terminal?
Okay, these two people joined new,
Yeah.
right?
Yeah.
Or
Yeah, I just want to make sure if anyone actually wants to like follow along and do it, that
I do it. I
You-
use
but if
IntelliJ.
not, that's
It
totally
is
fine.
fine.
Okay. Are
Intelligent
you all
works, yeah.
set? Are you following?
yes, I'm
Yeah.
following.
Okay, good.
Does anybody have a question before Marissa goes ahead with the examples? Do you guys feel like you understand containers and indexes and for loops and the fact that most of these containers have some method applied to it? Okay, it's all you.
What happened? Where did you have this open, on Safari or Chrome?
Chrome. So right click on the Chrome.
Ah, there we go.
There you go.
Okay. So, just a quick example on string methods. So, a very unbiased string saying Ernest Hemingway is the greatest American novelist. So, what do you guys think would be the output of string 1?
Replace the word greatest to worst and the upper. I mean capitalize it, right?
Yes. So, it's going to look like that, right? You replace the word and then you change it all to uppercase. What do you guys think is going to be the output of the second string?
Reverses, but not upper. Yeah.
Like all
It's
of
going to
those
replace
Replace
the
worst and
greatest with
awkward
worst. Ernest Hemingway is the worst American novelist.
That's what you think it's going to say?
Yes.
Okay, let's see.
That's a tricky one. I actually like that's very tricky.
So actually, it doesn't change because case matters when you're replacing things because strings need to look exactly as they did. So you guys are thinking like, okay, it's uppercase and you still replace greatest. You still replace greatest with worst. But what happens is first, you change the entire string to uppercase, so everything's in uppercase. So now greatest in lowercase no longer exists in that string, so nothing happens. It's not an error, which is nice, but nothing happens and you end up with only an uppercase string of the original sentence. Make sense?
Mm-hmm.
Okay.
This is an example of something that could bite you when you're writing
Yes.
code. You think it's doing this replacing, but it's not doing this
Exactly.
replacing.
So two things like order matters in how you apply your string methods, and also it's case sensitive.
How do you do the upper of a few characters within a sentence, within a string? Can you do that? Like
You
say the
would
word
do
greatest, you want to capitalize just the word. Greatest
right.
only.
So what you would do is say I only want to capitalize the name Ernest.
Yes.
I would go my string, and then I would have an index from 0 to
You have to locate
One,
the
two,
thing
three,
and capitalize those area only. Okay, understand your point.
it would
Yeah.
be 0 to 7, and then I would do dot upper.
Yeah.
Yeah, that's all you'd have to do.
Okay.
And then for the second example, does anyone have? Actually, it might be easier rather than eyeballing it if anyone wants to actually type this out in their console. It might take a while, actually. I wish I could just copy this. Let's just take a guess. What do you guys think the message says?
If not, all you have to do is on the Chrome tab, there's a replit session. You can just copy it.
Okay. Yeah, except that this is a picture, so I can't copy it. I just realized that.
Oh, okay.
Yeah. Anyway, this is just an example. So what happens is you're taking the entire message, so that's what the first and second semicolon, or the first semicolon means. It means you're going end to end. And then the final number is your step. So you're taking every second letter going backwards. Does that make sense?
So what it's going to do is it's going to get rid of all those big X's, basically.
Yes, exactly. Okay, so this is a bit of a challenge problem. I'll give you guys a couple minutes to hash it out if you want to try it.
We could
And
do.
let me know. I'll give you like a minute.
Yeah,
What do you
we'll
think?
give them maybe like 5 minutes.
Okay,
so
sure.
2:57 to try these out.
Okay. And then you guys can, once you finish, you can let me know what you think the difference is between these two.
Say that again, please. No.
So if you just see the string garble,
Uh-huh.
if you write that out into your console, if you have something set up, and try and process that string in two different ways. So one being message 1, you're going the entire string backwards with a step of -2. And then in the second case, you're taking the length of the garbled string up to the first index and backwards with steps of 2
See
again.
what it is. Okay.
So they're very similar, but they, as you can see at the bottom, the second message is missing the exclamation point. And I'll just let you guys play with that.
Just in case.
Okay.
So you can see what.
Perfect.
Is there a thing called undo? Because I made a mistake and I type it out. And is
Are
there
you just in terminal?
using IntelliJ? Is there a thing? I think.
Yeah.
How do you undo?
Oh, you're fine. So you can just go click up here and then just start typing.
No, I did type everything out, but then I hit a make mistake and
You deleted it back.
yeah. Oh,
There you go.
how did you do that?
Control Z.
Oh, Control Z. Okay. Oh, yeah, got it. Thanks.
Level 4 comprehensions.
Open. See what subject here.
I apologize for giving you such a long message to type out. I realize now it's probably a pain.
At least you didn't like have a full book.
Yeah. Let's decode this entire book.
Real life example, have like a ciphertext
Yes.
type thing. Have like a secret
Yeah.
message that people have to decode.
Yeah. How are we doing?
2 more minutes.
Alright. Did anyone get through it?
I think Chris earlier was saying that the second input, we don't grab the value from that particular object, right? So since you put 0, it still would not be retrieved.
Yeah, that's pretty much correct. So in the first one, you're going end to end, right? So you're saying I want the very first index and the very last index, and I'm going to skip every second character. So in that case, you get every single character. That's why you also get the exclamation point at the end. In the second message, however, so remember it's always start, end, step, right? So in this case, we're starting at the length of the garbled message, which is 47. So that means you're starting at the very end, so that'll be I. And you're ending at 0. However, remember, whenever you have a range, you end up at the last index before that. So you actually end at 1. So you end up at this X right before the exclamation point. Because you're going from 47, you're skipping 2, and your end point is 0, but remember it's up to but not including 0. So you finish at the character right before that, and that's why we don't get the exclamation mark. I'll just open.
Go to Chrome. Go down to Chrome.
It's
Down.
weird because I don't see it.
Down.
I know, but
No, down. See Chrome.
okay, I have to do that.
Right click on the Chrome.
I was like, it's not here.
There you go.
Excuse me.
Yeah.
I don't know how to transfer the letters into the messages. What's the garbled equals xe xg something like that, and then we use message 1 equal garbled change the index. How does it work? How does it transfer?
So the key to reading it backwards is
Oh,
the
got
negative.
it, got it. It's,
Yeah.
Eliminate all the big X.
Exactly.
Okay, got
Yes.
it. Thank you.
That's right. If you just put -1,
Mm-hmm.
it would just be the exact same message but backwards, and that wouldn't really help you. You might be able to see it better, but you want to get rid of those X's. So,
Yeah.
okay, so I'm just in case it's not clear to everyone, I'm gonna do one more quick example of this. So I'm going to spell hello backwards. Same kind of thing, but I'm not putting X's in between to make it confusing. And I'm gonna print this string from the length of the string up to its final index and going backwards in a single step. So what do you guys think this is going to print? Any ideas? Okay.
What's interesting is if you replace the length, when I was doing the testing,
Mm-hmm.
let's say you put 1,000, it will
Yeah.
still give you the same result.
Yeah, so it's funny, there's no limit really.
Yeah, like you just
It doesn't
go
give you an
find
error. Yeah. I feel like that's almost a bit of a bad idea because as a programmer, you'd rather it throw an error rather than have an unexpected circumstance because you can catch an error, right? So, just run this. Sorry, this prints hell. So, same thing, simpler example, but we're starting, so okay, what's the length of this string? 5. So we're starting at index 5. So O is 0, the first L is 1, 2, 3, 4. Okay? So in this word, so this is the 0th index, 1, 2, 3, 4. And I'm starting at 5 and going down to 0, but not including, or sorry, down to O, but not including, and stuff like that.
Chris, do you know why it allows you to start with the index of the census?
Right, because
mean the
technically,
I mean the first input here.
So in Python, the index beginning from 0. In this
Yeah,
case,
so a lot of programming languages, including Python, are zero based. That means indexing starts at 0 and goes on.
I have a question. You input print at s, the length of s. So the length of s is 5, right?
Yeah, it actually goes beyond.
And
Yeah.
we count from 5, the index 5 to 0, decreased by 1 every time.
Yeah. Yes. But
So we will
Because if
get
you do it at-
index
instead of
5,
at one, you do
index
it at
4,
1000, it
3,
gives you the same result, right?
2, 1.
I believe
not
so,
including
and
So
zero.
why
it's-
That's
should
why you
why
use
should
the
you start
O.
with
that's a
Yeah,
good
different.
that's like a good question.
What's that?
So that's like I don't know. I have to go look at like the definition of slicing on Python.org. There it should explain why it works.
Yeah, like Marissa saying, it's
Yeah.
not risky.
Because like if you look here, so this makes sense, right? Because here I'm going from 4 to 0. So the H would be index 4, 3, 2, 1, and that's why I don't get the O. This is what you would think would be like the correct way to grab HELL, right? But you can also grab it this way, even though the 5th index does not exist here.
Yeah,
I can even do this, right? So that's strange behavior, but anyway, just want to go through that with you guys.
that's interesting.
Mainly, like, I wouldn't worry about that. Mainly, I just wanted to point to you guys that 0 is not included because it's always
If you
up to
delete
and
0
not included.
here, what will happen? 0 will be.
You'll get everything.
Okay.
Yeah.
That's interesting. If we
Yeah.
put 0
Let's see what
there, it will not include 0.
Because -1 is now before the other one.
Yeah.
Yeah, I don't know. So I don't actually know why that behavior exists where you can hire an index and it still works. So I mean, that's really weird. But maybe under the cover, the implementation actually looks at finds the last digit that it applies to.
Let me get it back to percent.
And that might also, like in Python 3, that's the type of stuff they would fix.
Right.
Yeah.
I hope they do. But anyway.
But it's like weird things like that. That's what typically Python 3 fixes. But yeah, I'll look it up too because I'm kind of curious now. I didn't realize they implemented that way.
I just have to run an errand. I'll be back.
Sounds good. All right. So, was the practice problems pretty good?
Yeah.
Cool. So the next thing we're going to talk about real quick is lists. Now, when we were talking about strings, every single member of the string has to be a character or a string, right? We can actually generalize that to have a member be anything. It could be another container, it could be a number, it could be a string, it could be even something like a function. So in this example, we have a list, and that list contains a bunch of different types of members. So, the first 3 ones are numbers, the next one is an actual full string, you could have a single character, the last one's a word. And just like in the previous string, it supports everything that we mentioned before. So indexes, if you put 0 in there, it's going to pick 1 out. If you do -1, it's going to take all of hello of world out. So just similar to strings, you have all the same behavior. You can do slicing of the list. So if you did 1, index 1 to 3, it would take 2 and 3. And it also has for loops, and that's what these examples do. I just take hello world as a set of characters, and I'm just going to go through strings and things like that. I'm going to just show you that it is literally the same thing by going through an example of my own. So in previous examples, we had something like hello world. We could also have come on mouse, a container, a list, and we could do 1, 2, 3, 4, and maybe hello. And in the string, we could index it. We could grab a single index. If we wanted to grab the first one, it would be 0. We could grab the first 3 elements this way. I'm just double checking. And we, of course, have that for loop, right? For character in string, we can print the character.
Does comma work in between 0 and 3? It should be
Oh.
semicolon, right?
Good one.
What is comma? I don't think comma.
Comma
would
does
be
not
in
work.
it.
Yeah.
It has to be a
That-
toggle.
That's from like range getting to me.
Yeah.
And like previous examples, the index of 0 is H. The first 3 letters of hello is HEL. And we can iterate through it, so it's hello world as an iteration. And all these same things can apply to lists. So if we change all these things to C, and we call it M of C, and we do M here, we'll have the same behavior. So we can go up here, we can show this is a string. I'll do string in all caps so it's very visible. Here is a list. And I'll actually print both of those so you guys can see it on the screen too. Might as well, right? So really quickly, oops, do not press the save button. So string case, full string is hello world, first member H, slicing gets us hell. We have hello world iteration. And here for lists, we do the same thing. We can get the whole list. We can get the first member of the list with the index. We can slice the list, which will give us another list of the first 3 members. And then we can iterate through it too. So we can go through each member. And one important thing to note is just because this is a string does not mean that the for loop will string over it. It's its own single member that sits in that space. Does that make sense so far? So a list generalizes the same concepts we had a string, but now you can apply it to any set of objects.
Excuse me, I didn't get the loop. Do you set up the loop for M in C?
Yep, so the for loop was covered in the previous slide, but so I'll show you real quick, just so you can see what it's doing.
Okay.
So in a previous slide we had this. Basically how it works is when you say for M and C, M gets each member of this list. So we'll go M equals H, and then M is H in this code and it works. Then it goes to the next one. This is called, this process of each container has a reference to its neighbor and the ability to go to each of the containers and grab the variables. This is called iteration, or a for loop. And it will, for each member, it will execute some body of code, which is underneath in tokens.
Got it.
Yeah. Hopefully it makes sense, right? Yeah.
Thank you.
So that's what that for loop means. And let's go real quick. So we were doing lists, right? So conceptually that makes sense. You can mix it up. You can do whatever you want with it. Another thing you can do is you can have lists that contain other lists, which is also very interesting behavior. So a list that contains another list is pretty interesting. We can take this list here. A string is a container, but we can have other lists in here too. So you could do 1, 2, 3 here. And let's actually just do 2 container. We'll do 2 lists in this one. Let's do strings here. And this is actually a valid construct here. This is actually a list that contains other lists. Hey, what did you do? That was not cool. Okay, it was reloading. So you see, you actually have a list of other lists, and it behaves just like you would expect. So, you know, if you do print C of 1, C of 0, it's going to grab that first element. If you do the first index, it's going to get the second one, the next one. You can apply a for list just like it because the properties of the for list are independent of its members. So for M in C, for members in C, print each of the members out. And you can see there's 2 members here. But what's interesting about this is when you can reference the members themselves. So if you have C sub 0, that's our first list, right? That's now a reference to the list. If you wanted to get the first member of that child list, you just put a 0 here.
Let's see.
Do you guys see that?
Yeah, I understand.
And what's interesting about this is this notation is used a lot when representing physics in a computer science sense. When you have multi-dimensional arrays, they use this type of notation. So you have 0, 0 here, it gives you 1, right? we can also do 1 here. It now references this string array. We're going to get hello. You guys see that? And then if we want to go one step further for M in C, 0, because C0 is just a reference to this first list, right?
Mhm.
We can just print M. And that will go only through that first list.
Mhm.
And the reason why is C0 is a reference to a list, and lists behave the same way no matter what, is conceptual to understand it. Do you guys get it? And what's interesting about this is a list doesn't have to necessarily contain a list. There's all kinds of objects that a list can contain. But a list can contain more complex things too. And in one of the lectures to come, I'm actually going to explain why that is. There's actually a reason behind that. So this was kind of thrown in a little bit last minute, but there's this concept called a range, and it's just a special container which represents a sequence. So I think it's easiest to explain using REPL again. But range is a little bit interesting. Range just represents a sequence. So if you start with 1 and you go to 10, that last, just like in slicing behavior, the last one is where it stops at. So this will actually print 1 to 9. You guys see that? So range produces a sequence of 1 to 9. And I can modify that if I wanted to start at 5. So this is just a shorthand version of that. And this range object here is itself a list. So I can treat it just like a list. So here I start with 5, 6, 7, 8, 9, 10, and I'm printing each of those members within the list. A common thing people do is if they wanted to get access to the member number, I'm going to do, what's a good string? I'm going to use Marissa's name. So I take Marissa's name, and let's say I wanted to access each index and the value in that index, I can use a range function for that. So for M in, let's do C in S, range 0 to len of S, the length of S. Print S and what is it? Print C and S of C. Here we go. So this is kind of like a visual representation of an index, right? We have the range producing something from 0 to the length of Marissa. And then it takes each of those indexes and it just puts it into that object. Do you guys see that? So it's going to do from 0 to the length of Marissa is 1 to, what is that? Probably like 7 or something. So it's going to go generate a list of 0 to 7, 0 to 6. And then it's going to take that index and it's just going to stick it in the string and retrieve each letter at a time. So this is a common kind of way of representing both the index and the value simultaneously in case you want to do something like only if a certain index holds, then do this. You can do kind of complex logic with the indexes. So this is kind of what's called the most complicated part of the lecture real quick. I'm going to talk about a very strange concept which is called mutability. And basically, on a very high level, the way to think about it is the list itself is independent of its members. So if I assign A to some list, it is assigning to the list. There is no reference to the members at all. If I then take A, B, and assign it to A, it's still pointing at the same list. So I'll show you that real quick. This is very bizarre behavior, and a lot of Python channels, they look into this and they're like, what the heck is happening, right? So let's use A equals the range 0 to 5. I don't like that actually. Let's make it a little easier. So here's a sequence of 5, right? Pretty. That is not a sequence of 5. There's a sequence of 5, right there. Now, a lot of people think once I do this that B is a copy of this 1, 2, 3, 4, 5, right? I'm going to tell you right now, it is not. People always think it is a copy. And I'll prove it to you right now. I'm going to take that first element and I'm going to assign it to 200. And you expect both A and both B to be, you're expecting A to have 200 in the first one and B not to, right? Totally wrong. They both have 200 in the front. Do you guys see that? So you're assuming when B equals A that it's assigning a copy of that array. It is not assigning a copy of that. It's the same list. And when you modify A, you're actually modifying what B is referencing to. That's weird behavior. And this is a very important concept in computer science. There's this concept called mutability, which means the ability to change. And in Python specifically, when you have a reference to a list, everything inside that list is actually a reference to something else. They're separate sets of references. So I'm going to actually show you a picture of that because it's very hard to explain, I think, from just pure code. So here we go. A bit of mutability here. So when we did this exercise real quick, we had A equal 4, 5, 6. And just like what that does is it creates a list. And then it creates references to a 4, a 5, and a 6. When we say B equals A, it is making a reference to the same list. It is not making a reference to any member in the list. It's just making a reference to that list. Then when we do A equals 0, A0, the index of 0 equals 100, we are actually going to this item and we are updating the item. This item has nothing to do with those list references. It just happens to be contained in that list. This is like one of those problems. If you ever do a Python interview, they might throw you for a loop with this one. There's a lot of problems with that too.
And that's a design feature, and also a language.
So the mutability and immutability is kind of an advanced concept, but when you have multiple processes accessing the same object, if you have an immutable object, there's some sense of stability because this reference never can change. But for mutability, it allows you to do stuff like reorder the container, or reorder the references, or add or append. It makes an object more dynamic. And I'll actually, as we go through this, we're going to go through something called list methods. And a lot of those list methods can only be applied to mutable objects because they can be changed. Versus immutable objects, you can't change the contents of the actual members. But lists are mutable. They have this bizarre behavior where a reference to a list is different from its members.
I have a question. So how do you copy a list then? So you do want B to be exactly equivalent to list 4, 5, 6.
You want an exact copy.
Yeah.
Import deep copy. Deep copy.
Otherwise
that.
you have to recreate the list.
Yep. That, or you create list A.
Or you could generate, you could set B equal to an open list, or an empty list with 2 brackets, and then say like, for element in A, populate B.
I think the
and then you
easiest,
make your own list.
I believe the easiest way is you can list and then make a reference to the list too.
Mm.
There's ways to get around that,
Yeah.
but the idea is like this behavior is not what most people think, right?
Yeah.
Deep copy is common. Reinitiating the list is common. I think you can use list plus the list to make a new list because that's an initiating condition. The famous one's deep copy because it works on classes and functions too. Oh, and this is you.
Oh, okay. All right, more examples.
So she's going to go through some list examples.
Okay, so for the first one, you guys want to tell me what you think the first printout is? When I say print my underscore list at 0, what do you think it's going to print?
Yeah, 1A and 2
Yes.
or something.
Yeah. Okay, and I kind of gave it away for the other 2, didn't I? Okay, so, and if you want to access any elements within those, so this is a list of lists, right? So if I want to access the first element in the first list, I have to go my list at 0 at 0. And that gives me 1. If I want to access the second list and the third element it's my list at 1. It gives you this whole thing. And then my list at 1 at 2 gives me this third element. Because it's 0, 1, 2. Okay? Does anyone want to take a stab at doing the second one? Can give you guys a minute. Okay.
I like sevens for some reason. So 3,
Yeah.
7.
Okay.
That or you like 2. And if you don't want to type everything out, you can also go to the GitHub Innovators class thing.
Yeah,
That's
actually,
an
I
easy
should have
way.
told you guys that. Yeah, because all of these examples that we go through are in our GitHub repository, which I believe is linked in. Do we have like class notes or something?
It's
How is it?
under chriskotmeyer.com. There's a GitHub repo
Okay,
link.
maybe at the end we'll make sure you guys can go there because you can straight up just copy this code into whatever if you're using IntelliJ or something and
Just
play
run
with it yourself.
Yeah.
Maybe next time we'll make sure that you guys have access to that at the start of the class so you don't have to type everything out again.
What's cool about that repository, there's right now 85 different Python examples. So if you want to practice your Python and you have a different subject you want to tackle, all the practice problems are all there.
Is GitHub I'm not so sure. What is it? Is it like a
It's
files?
it's a change storage for code.
Do you have to
So-
have a software to be able to access
No.
that, or is it the web?
Yeah, just the web.
Okay.
It's public, right? It's
The-
public
It's
repository.
like the
It's
repository for
so
the developers.
GitHub.com
It's the
is
name
public.
GitHub.
GitHub itself is a product.
Right,
Yeah,
but
that's what I'm
your
confused about.
the
But the pub-
repository, anyone can see it, or do you need an account to be able to see the
You can
examples?
see any public repository if you want to. Yeah, you can see any public repository, but you can't. Yeah, I think you can even copy from it. So
I think we can
yeah, you don't need an account to interact with GitHub. But if you wanted to post your own code, you need an account. So you can read anything, but you can't write to it without an account. But the accounts are free, so it's not a huge issue.
Mhm.
These are great examples, by the way.
Awesome. Oops, sorry, guys. I want to open the Replit on the side. How do I do that? Your computer's
See the green button on the top left?
Ah, there you go.
Minimize it. Click. There, now you have Replit on the side.
Awesome.
I just find it even hard to read, so I just do
Yeah.
the examples off my head.
Oops, I don't want that. I can't make this. Okay. So yeah, you guys ready? Semi-ready to go through this? Did anyone get the output for the first one printed?
I hate how it does that with the lines right
I know, I don't like it either, because then it makes you think
That's
that,
what you get for having something on the web.
yeah. That feature's nice though.
Which one? Oh, the autocomplete?
Yeah.
Yeah, that's nice. Biggest problem with it being online. Okay, yeah. Yeah, I think the biggest problem with it being online is you probably can't build your own source code easily.
Yeah. That is true. Okay, so what do you guys think, what do you think this is going to print?
You're gonna have to start within the list and kind of lowercase.
Yes, this will. So this will print each name in the list, with the name being starting with lowercase instead of uppercase. What do you think this is going to print when I do line 6?
The original list.
Yeah, that's right. Because, so the difference here is within the loop, I'm printing each name in the list and applying the list method lower. So it's just like a string method, except I can apply it to a whole list. But I'm not actually reassigning that list. I'm just saying, okay, take this element in the list and print it. But I'm not reassigning that back to the original list. So when I print the class list, it's still the same as it was originally. So in the second case, if I do, say I'm doing pretty much the same thing, except now I'm going to assign class list for each element to its lowercase version. Now you see the list has actually changed. Does that make sense? The difference being, in this second case, I'm reassigning every element. So I'm going for range and length class list. So there's 4 elements, so it'll go 0, 1, 2, 3. So class list at 0 lowercase, that gives me lowercase Eric, here. And then I also reassign class list at 0, the original piece in the list, to the same thing but lowercase. So that's why you see the change here. But in the top case, no change because I'm not reassigning anything.
Yeah.
Does anyone have any questions?
So in the first case, she goes to the list, she just retrieves the object, and that object is temporarily stored there, then she's manipulating it. But that reference is just getting the value and then doing something with it.
Right.
In the second case, she goes through each of the references in that list and she reassigns it. And you have to do that reassignment if you want it to persist in the list.
Okay. Go back to presentation mode. I don't understand. Every time I click this, it doesn't
Just
go.
max it, I think. Because right now you got it on dictionary application.
Why am I in dictionary?
So for some reason Mac has like control frames.
Okay.
So it's really bizarre, but basically what it does is if the computer doesn't have the focus of isn't in focus,
Yeah.
none of that stuff works.
Sure.
Okay.
Yeah.
So do you guys get that?
On the previous,
Yep.
when in the second example of line 3, it says for I in range,
Dot
does the
instead
len
of comma.
have to be there?
Dot.
Yes.
So the len is taking
Okay.
the length of this, and it's implied that it starts at 0.
Uh,
So it's implying that there's a 0 here and it's going to 4.
So
But-
what if you put len?
If you so range has to take a number, so you'll get an error.
Yeah.
If range
to be
needs
an
a number,
integer.
yeah. But if you
But
wanted
it-
just to go through the list itself, you could just put class list. But in this example, she wants to show how to use the retrieval part.
Yeah. You could also do like for name in class list, print name, and that would give you Eric, Alyssa, John, Megan.
Yeah.
Yeah. You could do it either way. I think I just wanted to be more
She want,
explicit in, and also for the second case to be able to reassign, you need like an index. That makes sense.
then do you want to do the
No,
example?
I
Yeah.
forgot about this. Okay.
Let me see. Yeah. So after that,
Okay. You guys want to try this one too? This one should be pretty quick. Okay. So what do you think is the output of A?
Number 1, and the Q4 is 1, cat and cat. Right? No, what? skip the last one. So it's
Right.
x is 0.
Do we have a final verdict?
Definitely gonna start from 1. You're gonna do an official whatever, 3, 4, and then it stops.
Right. So it's only going to be 1 and this tuple.
Yeah.
3, 4. It won't print cat because it's up to but not including the third index. Okay, what do you think B is going to be?
That's gonna print true.
This one is tricky.
Yeah, because you're leaving out that first start, so it's going to assume it's 0, right? So it's not going to be just true.
Yeah. So remember, it's always start and end, right? So if you don't declare your start, it assumes it starts at 0. And your end, in this case, is -1. So I'm not sure if we went through this. I'm actually going to go back.
You did go through the negative.
The negative?
one. Yeah.
Okay. So, like, for example, here. So in normal way, 0, 1, 2, 3, 4, right? But if you consider the negative indexes, it's -1, -2, -3, -4, -5, right? So the final index in negative form is not 0. This is -1. And then this would be 0. Because there's like a placeholder. So in the case of this example, the value that holds the index -1 is true, but it's up to but not including the end. Okay? So it's everything except true gets printed. Okay? What do you think for C?
Maybe time for cat.
True.
Yep. So that'll print cat and true. And then what about D?
Everything.
Prints everything. Okay. So really, I think the only tricky one here is B, probably, right?
Yeah.
Is everyone okay with this?
5 true doesn't have a green quote.
So
Because it's a Boolean.
Boolean.
It's
Yeah.
a Boolean. So
So
there's
it's okay.
like three main types. Well, there's a lot of types, but that we can be concerned with is string, integers, Boolean, and there's float. Float basically means that it has a decimal point. So the only Boolean values you can represent is true or false or 0 or 1, I guess. But that also,
empty string, full
yeah,
string.
there's a lot of things that can kind of qualify as Boolean. But I think we'll probably go over that in another class, or maybe you already have.
It's already in class 2.
Okay. All right.
For
Yeah.
B, I thought it is inverse. The index decreased by 1, right?
Yeah.
And then do you have reorder everything? Or no?
So this one, you're sort of assuming that you're going with the negative indexes, right? So in this list,
Mm-hmm.
this would be, or sorry, let's start backwards. So this is -1, -2, -3, -4, -5.
Uh-huh.
And my end point is -1. So I end at true. But that doesn't mean I include this value. Because that means I'm going to go this one, this
Okay,
one,
got
this
it.
one. This is -2. So that's included in this range, right? Because it's up to but not including this index.
Just like the previous example contains 0 in the between the
Yes, exactly.
and that in 0
Yeah.
index won't
Yeah.
be included.
That's right.
If
Yep.
true word, the word true word not capitalized had to be in quote because
Yes.
not boolean.
Yes.
Yeah. True. The Boolean true has to be capital T then followed with RUE. That's the only way to get it.
Yeah.
If you do lowercase, it won't.
Okay.
All right. So I will explain this, but if you ever get lost on this, this is where I introduce the help command in the next slide. So all these are in the help command. But just like in strings, remember in strings we were talking about there's associated methods. Well, lists have a ton of methods involved. So you have everything from inserting an element into a specific index, so it will push it out, to you can remove the first instance of something. So like, let's say I want to look for, I have an A in the list, I want to remove the A. You can use the remove method to do that. Extend will take another container and just kind of append it to it, but in element by element manner. You have append, which will take a list and add it just to the list itself, like the full list. Pop will take the last index and just pop it off and then give it to you, so you can assign it to a variable. Count is just to count a certain member of a list. So I might be, count here works proper, but count doesn't work. Works differently in another setting. And then find is the same as the string command find. So I'll just really quickly show you guys all the code for this too. So we'll go real quick to Replit, and I will use her class list. I'll call it list because I don't like typing. So we're going to take her list real quick, and we can do list insert. Do we have a John? We have a John. I don't like this.
What?
What's another one? Max. I just want something else.
Yeah.
So a lot of list methods, they don't have a return type, and that's because they're mutable objects. So you're taking list and you're applying some operation on the actual list reference. So there's no return type. So I'll just show you guys real quick that. So in this case, I insert Max in between Eric and Alyssa. You guys see that? But I don't have to make an equal reference because the reference itself is the operation is being applied onto the list itself. What happens if I don't like Max? Maybe I don't really like Alyssa. I don't know why, I just don't like her. So I got rid of her. You guys see that? Got rid of Alyssa by using that. So there's a lot of these methods you can apply there.
What if you have more than one Alyssa in the list? Will it remove both of them since you didn't specify the index?
It only does the first one. By definition, I had to go Google that.
We just thought of that.
So let's say you have John, right? You have two Johns, and Alyssa got killed. If you do John here by itself, it's only going to kill the first one.
Yeah.
If you want to kill both Johns, you can do that. Oh, maybe not. Anyway, there's another way you could iterate through it or something of that nature. There's some method for that. What happens if I want to add a lot of different members, right? So Max, I'm going to kill these. Max, I like M words because they're not in there. Max, what's another, anybody
Mike.
other? Mike, okay. So if I wanted to add multiple members, I could do it that way. It's going to take this, and it's just going to take that reference, each of these elements, and it's just going to basically extend this list by applying them to the ending right there. Now, a lot of people get confused. There's this other one called append. Append is going to actually take the entire list of M words, and it's going to add it to the ending. So extend, each member becomes a part of the parent list. In append, we take the entire list and make it a member. It makes sense why you have to make that distinction too, because the list is different than the children of the list. Another one might be, let's say we have, I don't like append, I like extend, and I decide I want to take the person. I'm going to pop off Mike because he's the last member. And pop is just going to take that last index and it's going to show you, and it's going to assign it to the person and pop it off the list. So Mike is right there, and then if we print the list, we'll notice that Mike has disappeared from the list.
Can you specify which one you want to pop? Or is it always the last one?
This is how I find out this, because I don't do this enough. What is it? List.pop. Boom. List pop index.
Okay,
Remove
so-
and return index at default. So it's index based.
Yeah.
So that's index. Pop works that way. We had a few other ones that we were doing, right?
Mm-hmm.
I think we had a few other ones. Count and find. And find works just like you would assume, right?
Mm-hmm.
So if I wanted to find something that doesn't exist, monkey is good. Let's say I print that, it will return -1. I can print it. Has no attribute find. Did I get that wrong? Well, we could do count. So I might have gotten that reference wrong. You'd look at the help, maybe it doesn't have a find command. But you could do count real quick. What am I doing wrong today?
Maybe it just
Oh
needs
yeah,
an
I
index.
need to actually put
Yeah,
down
you
what
can
I'm
put
counting.
something in find.
So we can go print a count of something.
Mhm.
Yeah, that's what it is. Anyway, so if you're interested in different list methods, you can do help list, and it's going to give it to you. When I'm preparing these documentation, I literally go to the help section and I'm just looking at this stuff. And it's because, you know, I might not use all of these methods on a regular basis, or I might not know the ins and outs, but the help documentation helps a lot.
Yeah.
Alright, so we are on that. And this is the I hate remembering things. This is the slide about the help function. So that one's pretty obvious. Other things you can do is, these are, again, kind of data structures type stuff. You can do sorting algorithms over it too. So we will do that real quick. I'll show you guys sorting. Sorting is pretty cool. So let's say we want to sort something. Let's say this list of people. It should do a sort of each member. So if I sort it, remember I'm doing this on the actual reference itself, so I don't have to do any assignment. It's going to sort it. So Alyssa comes first, Eric gets to move here, John is here, Megan is here. And sorting is a pretty complicated task. If you ever do a college course on computer science, there's something called data structures and algorithms class. The first probably month or so is going to be sorting algorithms. So there's actually a lot of them. You don't have to worry about that. You just use the sort key, and they magically pick the best sorting algorithm for you. What about if I wanted to reverse the list? Like reverse it. You can do that. So there's a reverse command. And of course I have to print the list. So now I reversed it. I can also do a reverse sort by, there's a reverse key in here. You can do true. Now it's going to do a reverse sort. So there's a lot of different ways to sort, but let's say you wanted to sort stuff, or you want an easy way to find duplicates is you sort it, and you can figure out where the duplicates are, right? That's what a lot of people do in Excel, is they'll sort a column to see what duplicates exist. The kind of basic sort functionality.
Yeah.
Question, the sort and the reverse methods, do they change the original list, or
Yep.
do they copy over them?
There's no copy. You have that reference to the list,
Yeah.
and then it applies over that reference.
But it does change the original.
Yeah, that's what's important about mutability. If you have no separation of the members of the list from the list itself, you cannot sort. And actually, we'll talk about, there's an object that comes up in the next slide called a tuple. Tuples cannot be modified. You create a tuple once, it exists in perpetuity until the program shuts down. It cannot be changed at all. The only way to change it is you kill the reference and then recreate a tuple. And then that's not the same tuple anymore, right?
I have a question. For list sort, why just reorder the first two names?
So in this case, the reason it reorders is because Alyssa starts with an A and the other one's an E. The other ones are already in the correct sort order.
Got it. I see. Thank you. It's ordered by the first letter.
Yeah. So like if you were sorting something dictionary style or 1, 2, 3, 4, you're doing that kind of sorting. That's what it's doing.
Got it.
So it compares member by member, and it says, is this one a correct sort? You know, so like A has a lower sort value than E.
Yeah.
So it will sort it. You can kind of think of it like if I wanted to create a dictionary of things and I needed to sort it from A to B, A to Z, or things like that, that's what sorting does. And just a warning, this is based on ASCII scheme, so if you do a lower A, it has a totally different value from an uppercase A. I believe that I think you use ORD. You can use ORD to find that out, but there's a command for it. Each value has a certain, it's like a certain value for each thing. But most of the sort's pretty intuitive. So if you're thinking in terms of like your daily sorting, A to B, A to Z, capital A to Z, 0 to 1,000, that sort order is being applied in Python. And I think just so if people are more interested in this, it might not become the next lecture. It might be 2 lectures because I think there's too much material for this class. But the next official lecture, we'll probably go through a few sort algorithms. You'll do like a second year comp sci type exercise, but like the beginning week. And you'll see like a sort algorithm, a very basic one in action. Let's do a quick time check.
We could probably get some tuples in one challenge problem. I think that's probably the thing.
Yeah. So we can do dictionaries next time.
Yeah, I think that's a good place to leave off.
Okay, so the last thing we're going to talk about is lists. Like I said, there's a list reference, and then each member itself is a reference, right? There's another object that gets used occasionally, but not as common as a list because it tends to be not as powerful, where there is this concept called a tuple. And a tuple is like a list, but it's called immutable, which means its member references can't be changed. You create it once, you can't sort it, you can't remove it, you can't insert in things. The only thing you can do is read from it, so find stuff or like retrieve it but via index. Any type of assignment on this fails, and I'll show you that real quick. A lot of people are like, well, why would you need a tuple? Well, sometimes there's certain things like credit cards you don't want to overwrite. You don't want the risk of overwriting a credit card. You know, you want it one time and just only read it. So there's like a lot of safety built into this type of tuple. And immutability becomes...
Side note, lists are a lot better in memory because you're not storing as much.
You're not storing as much, yeah. But generally, like, one of the reasons... Yeah, so lists are better in memory, but if you have a lot of programs trying to access the same thing, you don't want them to change the reference. So I'll just do a tuple real quick. We're going to change this to a tuple, and I'm going to sort it, and you're going to watch this thing crash. Because I love crashing things. And it reloaded. Boom, crash. I can access like members of this list, right? Because that's reading the list. Reading the list. Yeah, reading the tuple.
It looks like a list. The only difference is the brackets.
Yeah. Hopefully I'm doing this right. We'll see. Oh, okay, yes. Because list doesn't exist. So I can access it, right? But if I try to do an assignment here, tuples cannot be reassigned ever. Do you guys see that? So tuples do not have a lot of functionality for a reason. It's to protect the data inside. Oops, runtime error. There you go. Look how little, how
The tuple is underappreciated. I don't use the one.
there's a reason they don't get used a lot. But you can see real quickly here, there is not a lot here. There's like, yeah, there's not a lot. There's not a lot of meat. There's not a lot of methods. There's a reason for that. It still does support anything that's a read. So, man, there we go. See that? So it still does reading, but you couldn't do any type of assignment with it, and that's what's important about it. Like I said, I've mostly seen this used in like databases where they don't want you to screw around with a record. Like, what's the point of changing it? Because, you know, data isn't supposed to be changed like that. That type of stuff. All right, so this is going to be the last one real quick because it's close to 2. Marissa's going to finish you guys off with the last challenge
Do you guys
problem.
have energy for one more problem?
There's going to be one last problem, and then I will come back probably jet lagged on the 16th.
Where are you going?
India.
Oh wow.
Well,
Are
for
you-
wedding.
When do you get back?
Like 11th.
Oh, okay.
So I
You've
might
got a
be
few
slightly
days.
jet lagged, yeah.
You'll be fine by then.
But we will, there's a second portion of this lecture. We will go through the second portion, which covers dictionaries, sets, and a very interesting concept called comprehensions.
Okay, so in this problem, we've got a word list, and it's a list of tuples. And I want to know for each pair in this list, if you reverse one, is it equivalent to the other? So a reverse pair is when you have one word and another word, and if you reverse the second word, it becomes the first word. So we can look, you know, mood and doom are reverse pairs, right? You reverse one, you get the other. So say I don't want to do it by eye, I want to use Python to do this for me. So do you guys want to try out how you might go through this list of tuples and determine if they are reverse pairs or not? And I'll give you a hint. It's probably best to start with a loop. You want to loop through each tuple and say, is the first element in the tuple equal to the reverse of the second element in the tuple? So we're covering loops, we're covering reversing strings, we're covering lists, and we're covering tuples. So kind of everything we talked about today.
This is a list inside the tuple. This is a tuple inside a
Yes,
list.
a list of tuples.
A list.
Yeah.
Got it.
It's like a tuple pair too, which makes it kind of interesting. Okay. What's interesting about this too, because she's using a tuple, you can't change doom or mood or anything of that sort. She's like locked you down to that specific list of objects.
How does Python know it's a tuple of a list?
So in the beginning, you have a difference between parentheses and brackets. Brackets are lists, parentheses are tuples. So when the minute Python sees a tuple with a bunch of things in it, it says, oh, don't initiate this as a list, initiate this as a tuple. And then later on, we'll talk about a concept called dictionary, and there's the curly brackets mean dictionary. So each one of those has a different start and end character, and that's how you determine the difference. one would be a good one for the comprehension section too.
Mm-hmm.
The list comprehension.
Give you guys like 1 more minute. Is anyone, you guys still working on it?
Do you know what this is?
Sorry?
Do you know what this?
Yeah, absolutely.
Trying to find out how to use it here. So we can use it.
So next time we'll just shovel this because we ended up perfectly in the middle. Oh, he's I met him at a barcamp. It's like a barcamp conference. He's trying to do. He showed up. He was in grad school. He's just like,
Oh, I can't
want
want
this
that.
stuff. That's like, well, that's cool. He just talked to me for an hour and then he hit it off so well. We've been friends for like 6 years.
Wow.
And he's getting wed right now, so cool. And his wife's awesome. Really smart. Very practical. Yeah, super, super smart. So she's at MD actually. Wow. So Indian MD can't remember. She's now MBA.
So I think double check that dot reverse
Statistical.
works, but basically the idea we have is
Mass General.
so the idea
Actually, I'm interested in.
You should connect us.
Yeah.
After the wedding.
Yeah.
Right now they're going to be
We
busy.
need to meet Cal right now, 2 days before the wedding.
Oh,
No, she's cool.
because now
I don't know if she maybe statistical, so it might be with operations. I don't know. She does something in between operations and stats. Smart.
oh, because it's double.
So
Her
Hey,
husband.
is dot reverse a string method?
It works on strength. I believe you can try.
Code brackets or dot reverse.
Try help. Worst case scenario, you can use reverse index step, right?
Yeah, that was the idea, but he's using dot reverse, and it's not looking, and I didn't use that either, but
Dot reverse, I think, only works on lists. But you can help on stir to find out that, I think.
yeah,
And they're very finicky because all those interfaces don't
right,
necessarily
because he has
work.
a string type, but then when he presses dot, reverse comes up as an option, but I'm pretty sure it's only for lists, so the Replit doesn't recognize that.
Replit is probably not smart enough
Right.
to figure. It just knows
It
there's a
doesn't know.
reverse method somewhere.
Yeah, exactly.
So-
Okay, so I think you've got the idea there.
You guys want to go through a solution? Yeah? Okay. Alright, so hopefully you ended up with something kind of like this. Okay, so you have a loop. You want to loop through all the elements in this list. So I went for I in range length of the word list. So that's 1, 2, 3, 4, 5. So for I in range 5. So I is going to be 0, 1, 2, 3, 4. Okay? And for each element, if the word list at the ith element, so first case I is 0, and you want the first element in the tuple, so that's where I grab this second 0. So this gives me, right here, mood. Okay, so if mood is equal to, okay, I'm at the same element in the word list, so I'm still at this same tuple, but now I'm grabbing the second element in that tuple, and that's the 1, right? And this is the part that reverses. So remember when we looked at strings at the beginning of the class? So I'm going start is 0, end is the length of the word minus 1, and then the negative 1 means I am reversing it. So I'm just taking the whole word and reversing it. So if mood is equal to this backwards, we have a reverse pair. And as you can see, mood and doom is a reverse pair. It works. Okay? So if this condition is not met, I go to this else clause, and I just simply print out that it's not a reverse pair. Okay, does that make sense, everyone? Do you guys have questions? Anything? And again, these will all be, actually they're all already on the GitHub repository. So maybe it would be good to take you guys there right now. Is it GitHub? This one? Or no, that's you. Just go here and then I'll take you there.
Or go to chriskottmeyer.com.
Okay.
So if you go to chriskottmeyer.com, you go to classes, and I'm logged in as admin, as you can see the 4 that are on the top.
Yeah.
And then you go further down, there's presentations there, there's GitHub repo there, there's a Slack channel there. If you have a chance, sign up for the Slack channel, ask questions there. Hangling, the other assistant, tends to go on there and answer questions. I answered a question or two as well on there.
Yeah. Yeah, so if you think of anything like after the class and you're like, oh, I wish I thought of that, you can just post it on there and one of us will get to it. And then, yeah, here within the repository, you've got all the materials from every class so far. So this will be in class 5. These lesson examples are ones that Chris used as he went through the class. And then the examples in here are the examples from me. You can go through here. Here's the code for the reverse pair list or reverse pair example. You can try different things. There are other ways that you can solve this problem. So, yeah. All right. Does anyone have any final questions or?
What's the website? Christopher. I think.
Yeah. So it's christopherkottmeyer.com.
Or Chris Kottmeyer works too.
Oh, does it?
Yeah, this is Chris Kottmeyer.
Try chriskottmeyer.com.
Yeah.
Just type it in real quick. Yeah. Watch what it does. Ta-da!
Whoa. Oh, and it defaults to Christopher Kottmeyer.
It's a DNS relink. Like redirect on a DNS level.
Nice.
That's all it is. I actually wanted it to stay to redirect to Chris, but I set it up the wrong way. But I was just too lazy to unset it.
Yeah. Right. Should I end the meeting?
Yeah,
Here?
tell them to go to where they can give the feedback.
Well,
Do
so
you have that section?
we have it, but because this is split in the middle.
Okay, no worries.
Yeah, we if you don't mind, go to Intro to Python blocks. Go to the presentation. Okay, and go to the very bottom where it's survey. Just copy that survey link. Just the entire slide. Copy the slide.
The slide.
Yep.
Copy the slide.
Copy slide. Now go up